Okay.
Good. And what about part C? How many people prefer cats?
I think I added all of the
Yeah,
numbers in this
23 in my case.
circle.
How many people were surveyed total? So if you add them, you get 54.
Yeah.
So included 6, I believe.
Actually, yeah, so it would be 60 in my version. But yeah. Okay.
All right, good question. Okay,
Sorry.
that's fine. That's great. That was a good question. So we have our exam this Wednesday. It will be super important exam. I'm not saying complicated exam. I'm saying important for people who didn't do very well on the first exam. So that's a good time or to show me that you guys know the material. All right. So if you didn't do
How
very well
many
in the first
questions will
exam,
there be?
say again, please.
How many questions will be on the test?
I don't know. It's too early to ask. But your camera should be on. I mean, I don't want to. I will make a different room for each person, so not everybody. Like last time, it was kind of confusing. People were hearing each other, but now I will make a separate room for each person to take the exam. And if the camera is not okay, the lighting is not okay, and I don't negotiate, I just lock you out, and I don't. I mean, I mean, I will not consider your grade.
Um, with
More pictures. Anyway, in the last section of chapter 4, there are, I'm assuming that you guys watch all the videos in chapter 4. So now, only few important things for section 4.5 is about bootstrap and randomization distribution. So so you should be able to find the difference between bootstrap distribution and randomization distribution. We learned about bootstrap on chapter 3. Randomization was about in chapter 4. But the big difference, a randomization distribution assume null hypothesis is true, while bootstrap distribution does not. And let's have one example. Which distribution? So which distribution below is bootstrap distribution? So your note sheet, you should have all the characteristic for what the bootstrap. So let's read the question. And that's what's going to happen today's session. I'll just give you guys question and you guys try to solve it. So let me be the average amount of sleep. So the word randomization distribution and bootstrap this, I mean, all of them, it should make sense to you. So which one do you think is a bootstrap? We learned bootstrap will be centered around the A or B. Anybody?
Would bootstrap be A because it's centered around the 6.7?
Very good. It's centered around the sample statistic. So bootstrap will be, the characteristic of the bootstrap, but it goes around the sample, the statistic. Another question, same graph. Which distribution is the randomization distribution? So we learned that randomization will be, so the bootstrap distribution, let rho be the proportion to, so rho greater than 1/2. So this is 1/2. It's centered around 1/2, which again is A, is centered around the null value. That's the characteristic about randomization.
I'm sorry, so can you go back to the previous one? So the bootstrap is centered around
The
the
sample,
mean, the sample mean, or?
the sample mean. But the randomization goes around the null hypothesis.
And how do we know what the null hypothesis is by?
So here we have, so they said this is like a rho more than 1/2. So the null hypothesis will be rho equal to 1/2, and alternative will be rho greater than 1/2. So this will be the null value.
Okay.
Professor, would the questions be pretty much like this on the exam?
Yeah, the most of the question that I prepared today will be similar to that. I mean,
Okay.
this is there's no challenging. You need to know the characteristic of randomization. We need to know the foundation.
Okay.
There is no surprising. Interval tests. So this is new on the section 4.5. A confidence interval represents the range of plausible value for the population parameter if the null hypothesis value is not within this confidence interval, it is not plausible value and should be rejected. Can I have a couple examples? If the null hypothesis value is within the confidence interval, it is plausible value and should not be rejected. So let's have the example. So this is another way. If a 95% confidence interval contains one waiting list. If a 95% confidence interval contains a parameter in null H null, then the two-tailed test should not reject null hypothesis at the 5% significant level. if a 95% confidence interval meets the parameter in H null, then the two-tailed test should reject H null at the 5% significant level. Example. So, should we reject it or not reject it? In basically these two. We have confidence interval, 95% confidence interval with rho is between 0.533 and 12.607. So the null is 0.5. The value of null is 0.5. Should we reject it or not reject it? So what we have here, oops, they said the parameter in H null, which what we have 0.5, I believe. They should not reject H null. If the parameter H null, so it contains a parameter. So in this case, 0.5, is that between this confidence interval?
No.
0.5 is not, so we will reject it. So the solution is 0.5 is not within the confidence interval, so it's not plausible value for P. So we look at the value of null hypothesis. So 0.5 in this interval. Let's have another example. What about this one?
So on this one, would it be the opposite because it is within the interval? So
Very
we did not reject.
Very good. We do not reject. So on last week we learned that when we don't reject it, doesn't mean we reject the alternative hypothesis. We just say we do not reject it, correct? That doesn't mean we accept null hypothesis. So 0.5 is within the confidence interval, so it's plausible value for P. All right, let's have review question here. Write down the, so this is a type of question you will see. So you need to tell me what is null hypothesis, and what is alternative. What do you think the null hypothesis will be? So we need to know if there is evidence so that the mean level is greater than 100. So this will be the alternative. So alternative will be mean more than 100. And for the null hypothesis, we always use equal sign. We say mu equal to 100. Given a possible sample mean that you think would show strong evidence against the null hypothesis and its support of the alternative hypothesis. So give me a sample mean, like what is X bar should be to be against null hypothesis.
Anything over 100, right?
Very good, yeah. Anything over 100, okay, yeah, 120, whatever. If over 100, if X bar is more than 100, any number, then is supporting alternative against null. Ryan, does that make sense?
Kind of. I'm a little confused still though.
Okay. You guys, did you watch the videos on the chapter 4?
I haven't yet, no.
But you should, I mean, I know some of you guys haven't done that yet, but please do it before the exam. It's not complicated. If you know it, it will be super simple. If you don't know it, it will be complicated. And this looks complicated to some people because you guys don't learn about null and alternative hypothesis very well. But if you learn it, it would be the same as 2 plus 2, is that easy. And if we don't, you need to do it for, you need to know it for the exam. Also, we need to know it for the next chapters. We deal with this for entire semester. So try to be friend with it and love it. What about, given a possible sample mean that would definitely not show evidence against the null hypothesis? So now we're going to be good with the null hypothesis.
Will it be 100 then?
Very good. Very good. That was you, Ryan?
Yeah.
Very good, yeah. So,
Right.
I mean, the alternative hypothesis is something that we need to investigate. We apply statistic to it. So here, so after coming up with this two, they said evidence against to not show evidence. So something equal to 100, no, X bar equal to 100 or less than, because we need to prove is more than, so 100 or less than. This is actually the solution. You guys can take a picture, but the way they worded, you need to make the same wording in your exam. And the good thing is all of them, they're similar.
Will you be sending this to us through email, or is it going to be on YouTube?
I will make it, I should be able to put that on the YouTube, yeah.
Okay, thank you.
Sure. But you can just take a picture now. But anyway, so let's move to the next question. Write down the hypothesis for the test in each case below. Does the proportion of people who support gun control differ between male and female? So we need to have null and alternative hypothesis. Null always has equal sign, and for the alternative we have less than, greater than, or not equal to, correct? Or sometimes equal to as well. But in this case, we have equal as well. But it's a differ between male. They didn't say greater than or less than. So we are dealing with this one, correct? So alternative will be between male and female. What should we use? Should we use mean or row or R? So which parameter should we use here? They said proportion, correct? So we should come up with the proportion. So proportion of male is not equal to proportion of female. What is null hypothesis? Null hypothesis says, oh, P of M equal to P of F. So in this question, they just ask us to come up with this hypothesis that we have. Who wants to answer part B? What is H null? What is H A?
H null is mu equals 7.
And what is
H
Is alternative mu less than 7?
Very good. So again, for null hypothesis, we always use equal sign. And where did I come up with this? Because they said less than. Good. They cannot ask a question about the null. They always, this, whatever they ask, there's something that's challenging the alternative hypothesis. Because that's why we can apply statistics. So much easier to come up with the alternative first, and then you make the null hypothesis. And this is the solution for what we did. And we did correctly, yeah?
Professor, do you mind going to the last problem really quick so I can screenshot it really quick, please?
For part B?
No, the other question that we just did before this.
This is the solution. This one?
No, the one before, the complete different, that one. Thank you so much. All right, got it. Thank you.
That was a long, noisy flash. Good. So where were we? We are here. We did this one, correct? We came up, we answered this question.
Yes, that's that one.
We have this one. So again, few example, 4 or 5 example like this, you will be master. I mean, all of them are similar and easy to get points. Mariana, do you have a question?
Not right now.
Ray?
No, but I have to step away from my camera for a couple minutes.
All right. Come back. So let's have another question. So there are only two, we are only dealing with chapter 3 and 4, correct? So what's happening here. This. Sorry guys, there are two different layers got connected that should not get connected. But this goes, this comes. All right. So I was saying the exam is on chapter 3 and 4. So all the terminology or the keyword, you need to make a beautiful note for yourself to take the exam. Back to Na's question, she said, how many questions you will see, I will make an exam, not that many questions. We are limited to the time, and I'm not gonna challenge you guys with the difficult question and too many questions. As long as you know the concept, you know you have enough time. If you don't know the concept, there is no way you can Google it or just learn it at that moment. You don't have time for this. So my point is, have a good note sheet for yourself for chapter 3 and 4. Good. So ESP, that was something that we talked about it in one of the lectures 3 weeks ago. If no ESP, what expected P will be? So you need to know about ESP, the game or whatever, they read the mind. So if there is no ESP, what is the proportion? What's the probability that you get A, or you get B, or C, or D, or E? The expected probability will be, or proportion will be, you have 1, 2, 3, 4, 5, will be 1/5, which is 0.2. That means if I pick one of the card which has A, B, C, D, E on it, what's the probability that you will say it correctly? The probability is 1/5. Because 1/5 is correct. But if ESP exists, I mean, if you can read my mind, then the probability will go higher. But here they said, if no ESP, if there's no ESP, so the probability is 0.1/5. What's the answer for part B? So those are the sample 0.1, 0.25, 0.4, 0.7. They said which sample proportion crack would provide the greatest evidence that people have ASP? Extensory perception. Which one? Man, period, which one you think it will be?
To be honest with you, I do not know, but something's telling me to lean towards 0.4.
The way the question is kind of confusing, but they are the question saying, if we believe ESP, that means if you pick a card, then I can read your mind what the card you picked, correct? So then the probability will be, the highest will be like a 0.7. 0.7 has the highest probability. That means they said, which is the greatest evidence that people have ASP? This will, 0.4 is okay. 0.2 is the one that we don't believe ASP. But if somebody believe ASP, that means they can read your mind, then the probability gonna go higher. So 0.7 will has a highest proportion. Write down the null and alternative hypothesis for testing whether people have ESP. So ESP is extra sensory perception. So now we're going to have null and alternative hypothesis. Write down null for testing whether people have ESP. So people have ESP. So if they have ESP, what do we know about the proportion?
Should be higher than 0.2 or higher than 1/5.
Very good, very good. So alternative will be P will be greater than 0.2, but the null hypothesis see P equal to 0.2. I use P, not P hat, correct? Anytime we're dealing with the null and alternative, we deal with the parameter for the population. But for the sample, we use P hat. If you put P hat here, it will be wrong. Because P hat is for sample. Null and alternative dealing with population.
Can you explain one last time on how you get 0.2 for both of them?
How did I get 0.2?
Yeah.
So 0.2 here, we have 5 cards, correct? You have A, you have A, B, C, D, E. If I put them in the bag and I randomly pick one of them, what is the probability that I get A?
0.2.
Is 1/5. You have
Yeah,
1/5, which is 0.2. That means, no, I pick one letter, correct? And then I ask you what letter is that? What's the probability that you be correct? Is like a 1/5, for example, if it's A.
So for C, the null hypothesis and the alternative hypothesis is just going to be the same as the one we got for A, which is 0.2.
Okay, that's a good question. Then, so here they said, write down the null for testing whether people have ESP. If there is a ESP, so the probability gonna be more than 0.2.
Oh, okay, I got it.
Good.
Yes, thank you.
So have ESP, not necessarily 0.7 or 0.4 or 0.25, should be more than 0.2. I mean, the sample means we're gonna try it with 100 different or 1,000 tests. If the probability is more than 0.2, that means there is a ESP. That's the way, that's a solution. If you want to take a picture. All right. Another question related to null and alternative hypothesis.
not mu, not mu. Shoot.
Very good. So this is
P?
very important. P, very good. So
P. P is P should be less, more than, greater than 8.
greater than,
Can
more
choose
than
more
half
than
the
half.
time.
Oh, so we just write 1/2 then.
One half, yeah.
Okay.
And what is alternative? What is the null hypothesis?
No. Should be P equal 8.
Where'd you get
A point.
eight?
Or have to.
Correct. 8 times. That's nothing. This is n equal to 8. So null will be P equal to 0.5. I mean, half of the time is correct. But alternative said choose correctly more than half the time, more than 50%. Good. So now what is Paul's sample proportion? What this octopus did? What is the sample proportion? Only
Would
for
be-
this case.
Would
What
be
was that?
1. Would be 1 because he got it everyone right.
Excellent. It's 8 out of 8.
Yeah.
This sample was 1, but we cannot reject the null hypothesis only with this one sample. But for this case, it was 100%. But this is a null and alternative hypothesis. That's the solution. Another question. So we are dealing with randomization to test null hypothesis mu equal to 50 versus alternative hypothesis less than 50. Using sample data with X bar equal this. Where will randomization distribution be centered? I'm sure Steven can answer this. Where? Mariana?
Is it always centered around the null hypothesis?
Very good.
Yep.
Yeah. So it would be around 50 for randomization, correct? Is this a left tail test, right tail test, or two tail test? So around 50, mu equal to 50. Is that left, right, or two tail?
Should be
Right.
2 tail.
Two tails happens when we have like this inequality.
Oh.
Right, that means we are dealing here. Left, we are dealing here. So we look at the alternative, mu less than 50. So it will be this side, left.
It would be left. Okay.
This is a solution. So at 50, right, that's what we said, but this is more details for you guys. For randomization, we must assume that null hypothesis is true when we create the randomization distribution. Next question. I'm pausing the video and then recording it. When I give you guys time to solve it, so I pause the videos. So you might see a jump on the YouTube. I just want to make the video shorter that doesn't take a lot of space. All right, let's have another question.
Can you go back to the last one real quick?
Sure.
Okay, thank you.
So in each case, which p-value provide the strongest evidence against H null and for HA? Part A, between these two, which one provides the strongest evidence?
So the smaller the p-value, the evidence against the null.
Excellent. So 0.02 will be correct for the first one, and for B, 0.008, correct? As you said, the smaller p-value, strongest evidence to reject or against H null. So this one, this one. Again, if you know it, pretty simple. It takes less than 10 seconds to just find it. If you don't know it, if you want to Google it, if you want to call the friends, not going to work. All right. So let's have another example. So because p-value is less than alpha, for part A, we're going to reject H null. So you need to say there's evidence that metabolism is higher after receiving resveratrol. Let's worry about the rejecting or not for now. Then I show you the solution. For part B, to be rejected or not?
Would you reject it?
Yes. Reject H null again because this is super small actually. Part C, this is more than alpha. So do not reject. Again, do not rejecting H null doesn't mean we accept alternative. Part D, this is less than alpha, reject H null. Part E, which of the result given A to D above are significant at 1% level?
C, because it's the largest.
No, significant at 1% level.
Oh. I have to look at my.
I mean, the only B, correct? Only B 0.007 is less than 1%. So here actually they make the alpha smaller. First alpha was 5%, but significant at 1%. Which of the result given A to D above are significant at 1% level? When alpha equal to 1%, only this is less than that. This is a solution that you get. we give p-value for 4 different tests. Which of the tests are significant at 10% level? At 5%, at 1%?
Yes.
So B is yes. What about C?
Yes. Okay, so there could be multiple.
Yeah. And also D,
D.
0.09 also is less than 10%. Good. Just need to compare it. This is a p-value which we get. Okay, here the area here, and this is alpha. When alpha is 10%, is a p-value going to be inside or is going to be here?
Okay.
What about at 5%?
Would it be the same answers, B, C, D?
5%. What about 0.09? Is that going to be?
Oh, snap. No. Okay, so
We
just.
don't want to do those mistakes. Yeah, B and C.
Okay.
What about at 1%?
Just B.
Just B. Very good. So part B now, using a 5% significant level, give the formal conclusion for each test. So formal conclusion for test A, do we reject it or not reject it? The null hypothesis. Is that p-value and 5%. Should we reject the null or not reject the null?
We do not reject it.
Very good, because it's more than that. We do not reject it. So do not reject it. So actually, let me show you the solution. So test A, do not reject it because p-value 0.23 is more than 5%. Test B, we reject it because it's less than 5%. C, reject, and D, do not reject. Correct? D is more than 5. Using the confidence interval. The conclusion. So this is something related to this last section in chapter 4. So reject H now. Ryan, what do you think? Should we reject H null or not? What is the value of null?
The value of null says that they're equal to each other. P1, P2. So we would reject it if there's a difference then, right?
So same as one of the previous example, P1 equal to P2. If I ask you what is the value of that, previously we had 0.66 and 0.64.
Yeah.
Then you said this is more than this, and then I subtracted,
Mm-hmm.
right, to find the value. Here, if P1 equal to P2, then P1 minus P2 equal to
0.
0.
Yeah.
Is 0 between this interval?
Yeah, it is.
So we don't reject it then.
Okay.
Good. This is the solution. Better wording. So they did subtract the difference of 0. So reject, not reject. This one. So first one is no, because the sample size doesn't match. Second one, yes. Third one, no. 5 is out. And last one is D. Pretty good. Let's have another one.
Can you go back to the last one just for a second?
For a second, for sure. More than a second.
Okay, thank you.
This is more than a second for you.
Oh, I already got it. Thank you.
All right. Describe carefully how we could use cards to create the one bootstrap statistic. So let me show you guys the solution is much easier. So getting 101, you just add them, then divide it by 10. And you, to create the bootstrap sample, we put them inside of the hat. We pick one, we put it back, correct? That's how bootstrap works, right? This is the favorite question for Stephen. Where will the bootstrap distribution be centered? For bootstrap will be around the sample mean, correct? For randomization was around the null value, but for bootstrap will be centered approximately at the sample mean of one.
Why do, and then the second part says we expect it to be bell-shaped, and is that just because we're doing the same 10, we're drafting the samples from the same 10?
That was the beauty of the bootstrap, that at the end we will get something like this, and
Okay.
this will be. That's the entire bootstrap thing.
Okay,
I know
so
it's kind of,
bootstrap is always bell-shaped.
yeah. But if you take enough sample, like 1,000 or 2,000.
Okay.
The last few example looks like I didn't hide the solution. Well, let's, okay. So this is chapter 3, beginning of chapter 3. We learn about the margin of error. Good. Let me know if you have a question here. So again, this is very important. For the margin of error, we add and subtract to find the interval. We find 0.41, 0.47. Good. And here they're asking us, is 0.42 lies in the interval? No, 0.42 is plausible value for the population proportion. Because 0.42 is between the interval, we say yes, but 0.50, no, is out of the interval. So that was a margin of error. We just add and subtract. This one is for a standard error. For a standard error, the formula was plus minus 2 times that, right? Good. The last one